Welcome to this explainer. Let's dive right in, because today we're looking at a major technological shift happening quite literally right under our feet. We are unpacking the 2026 quadruped robotics landscape. Now, if you've only been casually following robotics, you might still think of robot dogs as, quirky internet videos or just neat laboratory experiments. But today, we're going to look at the hard data, the actual hardware, and the very real geopolitical realities of an industry that has aggressively moved out of the lab and straight into the real world.
Picture this for a second. A four-legged robotic machine weighing under 20 kilograms, sprinting across the frozen, fractured ice floes of the Arctic Ocean. It's using wide, biomimetic paws, actually modeled after polar bears, to grip the ice, and it's processing its entire environment with thermal imaging and LiDAR, completely autonomously. This isn't some fancy concept rendering for the future. Nope. This was a real-world deployment of a Chinese quadruped robot in mid-2026. The era of the all-purpose lab marvel is officially over, and an active army of specialized robots is already deployed out there.
Before we get into the heavy industrial applications, let's ground ourselves in the engineering itself. Consider how the mechanical chassis directly compares to the anatomy of a biological dog. You can clearly see the biomimicry at play: the hip, the thigh, the calf joints. But instead of muscle and bone, we're looking at high-precision actuated joints, complex sensor arrays on the head, and incredibly robust data transmission modules packed into the spine. It's essentially a form factor designed by nature, but perfected by engineering to conquer broken, uneven terrain that standard wheels or tracks just simply cannot handle.
So the crucial point here is understanding how the global approach to this technology has fundamentally split. The United States has historically dominated this space by building all-purpose, singular icons. Think of those incredible viral videos of Boston Dynamics' Spot. It's really about engineering the ultimate singular machine. The Chinese approach, however, is radically different. Instead of trying to build one robot that does absolutely everything, Beijing's industry is deploying a highly integrated ecosystem of specialized robots. They're building a perfectly matched team for every conceivable environment, from high-speed scouts all the way up to heavy-duty haulers.
This ecosystem relies on a highly specialized roster. First, you have the Lynx S10, an agile scout that hits 8 meters per second. Then there's the M20S, a mid-size industrial robot hitting 9 meters per second. Up next is the X30, a solid 56-kilogram patrol robot. And finally, the heavy haulers from Unitree, the A2W mechanical mule that easily climbs 40-centimeter steps, and the massive B2W that can comfortably support 120 kilograms just standing there. The strategy here isn't to build one machine to rule them all. Actually, it's to ensure that the exact moment a specific real-world operational gap appears, there is already a specialized robot ready to fill it.
Section 1. The Specialists. From Arctic ice to industrial tunnels.
Let's start by looking closer at the Deep Robotics Lynx S10. This is the agile scout I mentioned just a moment ago. It weighs under 20 kilograms, which makes it light enough for a single person to easily deploy. It reaches a top speed of 8 meters per second and clears half-meter obstacles effortlessly. And yes, it's the exact model that recently conquered the Arctic sea ice. It functions as a compact, highly mobile sensor platform. But here's what you really need to take away from this. Mobility in extremely dangerous terrain is fantastic for scientific researchers, for sure, but that exact same mobility and dual-use potential is equally valuable for border security and military reconnaissance. Next, we step up in weight class to the M20S and the X30. The M20S uses dual ultra-wide-angle LiDAR for full scenario path planning at really high speeds. But the 56-kilogram X30 is where we see the gritty industrial reality come into play. This machine persistently patrols power substations and toxic environments. It's fully equipped with thermal and acoustic sensors, literally listening for electrical discharge and tracking abnormal heat signatures. It even features hot-swappable batteries. It is systematically replacing humans in the dangerous, repetitive, sweltering jobs that, frankly, none of us want to be doing anyway. Then we have the heavy lifters from Unitree, the A2W and the massive B2W. Now these are wheeled-legged hybrids. They use wheels for high-speed transit on flat ground, but the very moment the terrain breaks, the legs activate. The A2W is basically an all-terrain mechanical mule, navigating 45-degree slopes like it's nothing. The B2W pushes a massive 360 newton-meters of joint torque. To put that into perspective, it can support the weight of 2 full-grown adults, 120 kilograms, and can continuously haul a 40-kilogram payload over fractured logistics routes.
Section 2. The Engine. How China Scaled So Fast.
So how did this happen so incredibly fast? Well, by the first half of the year, Chinese manufacturers captured a staggering 97% of global humanoid robot shipments. A massive 90% of Unitree Robotics' supply chain is completely domestic. All of their core components are fully self-developed. This wasn't pieced together from a fragile, spread-out global supply chain. This is the direct result of incredibly dense, clustered manufacturing in places like Hangzhou. When you control the refinement of critical minerals for robotics magnets, and your component suppliers are quite literally right down the street, you can iterate from prototype to deployment at a blistering pace.
But it's not just geography, right? The growth drivers here are really a perfect storm of policy and technology. You have top-down industrial policy with government subsidies and cheap land heavily backing these companies. You have a vast domestic manufacturing and warehousing market that acts as a real-world testing ground for frequent, rigorous engineering validation. And critically, you have a booming AI sector. In fact, Chinese AI models recently surpassed the US in downloads on platforms like Hugging Face, driving rapid advancements in embodied intelligence. This blistering speed, going from prototype to real-world deployment, is exactly why Silicon Valley is watching this ecosystem with intense concern.
Which brings us to Section 3. The threat: civil-military fusion.
This rapid scaling has absolutely triggered alarm bells in Washington. A recent joint investigation by the U.S. Select Committee on the CCP and the Committee on Education and Workforce resulted in a very stark summary. They stated, quote, "American taxpayers are funding research collaborations that pose a national security risk to the United States. We are providing backdoor access to the very foreign adversary nation who we must build these military capabilities to defend against." End quote.
The committee detailed a very specific pipeline to explain how this actually happens. Step 1. The U.S. provides federal or Department of Defense funding to American academic researchers. Step 2. Those researchers then form partnerships or joint institutes with Chinese universities. Step 3. Under a policy known as civil-military fusion, that open academic research is transferred directly into China's defense and tech industrial base to build autonomous weapons and next-generation military systems.
And the technologies identified in these case studies, they are incredibly high stakes. We're talking about artificial intelligence, advanced robotics, hypersonic technology, next-generation nuclear physics, and drone swarm control. This is exactly why the Pentagon views these quadruped robots not just as helpful industrial tools, but as highly capable dual-use platforms. A robot that can carry gas detectors in a civilian tunnel today can just as easily carry reconnaissance payloads or coordinate with drone swarms in a conflict zone tomorrow.
Section 4. Washington's response: the 2026 import restrictions.
This leads us directly to the consequences of those security warnings. In 2026, Washington advanced strict FCC import bans explicitly targeting advanced Chinese humanoid and quadruped robots. Analysts note this is a massive direct hit to a Chinese industry that accounts for 85% of humanoid deployments globally. Washington's primary goal here is to forcefully keep this technology out of American infrastructure, viewing the deployment of these networked autonomous machines as a major potential flashpoint heading into the planned Trump-Xi summit.
To really understand the root of Washington's fears, consider the technical schematic of a remote-controlled data transmission module from a standard robot manual. Notice the digital transmission module, the Bluetooth connectivity, and those complex digital interfaces. When you have highly capable sensor-packed machines connected to vast data transmission networks operating inside critical infrastructure like power substations, logistics hubs, and research labs, the concern entirely shifts from just hardware superiority to profound questions about surveillance, data control, and deep hardware dependence.
Which brings us to the ultimate question for this explainer. The United States still holds some of the world's absolute pioneering foundational robotic technologies in the laboratory. But China has successfully embedded an entire, highly flexible robotics ecosystem out into the real world. Victory in this technological race isn't going to be decided by lab specifications alone. It's going to be determined out in the field through endurance, mass manufacturing, and real-world reliability. So as these robotics specialists step out of the shadows and into our daily industrial lives, who really holds the advantage? Thanks for joining me for this explainer, and I really encourage you to keep exploring the data on this rapidly evolving topic.